Hello and welcome to Woodworking. Today's video, I want to take you through my budget CNC, an alternative to paying $3,000 or $4,000 for a CNC. If this is not your thing, then wait till my next video and I'll have something that might be more in line with what you're looking for. But we're going to cover this today, take you through some projects, take you through, the construction of this and kind of why I chose this and things like that. So stick around. So let me start off with, I am not sponsored by any of these companies. This is, I paid for everything with my own money. I did my research and settled on this. If you've watched some of my earlier videos, the CNC I was using was what's called an MPCNC. It is made out of electrical conduit and 3D printed parts. It worked great for a beginning, and maybe that's where you want to start. I think all in, that's about $500, minus the cost of the 3D printer. So, that's an entry point, and that's where I started with. That's what I wanted to learn on. This here, all in with everything besides the cabinet, which is made of 3D printed parts, but the good thing is they're not at critical junctions, so it is very rigid. You can mill aluminum on here, and of course wood. But all in, probably right around $1,000. I didn't buy this all at once. I sourced the parts over the course of a year. So I would, save up my money. I would get a few parts. And then, when I'd have some more money, I'd get some. And that was from either, YouTube revenue, which is very small, selling of products, things like that. I would just dump right back into purchasing tools, and this is what I spent a year collecting. I also want to say this is not complete. There are still things that I want to do, and I'll cover at the end of the video what are some of the upgrades, some of the things that I'm going to change, and things that I need to still finish. But it is cutting. I've already flattened the spoil board. It does have about a 23 by 33 cutting area. You do lose some of the workable space. It's kind of big, but you lose some of the workable space because of how far the spindle sticks out and things like that. The spindle is a 110 volt, I should say, 2.2 kilowatt water-cooled spindle. I do have a bucket back in the back here with a pump, and it just uses here in the US regular 2x3, I forget the wall thickness, but I think it may be an 1/8 inch wall thickness, and it might have been a little thick. I do have, I purchased from one of the members on Discord, the spindle mount, the Z-axis, that's made out of aluminum. I did have wood, didn't think it was rigid enough, so I did purchase that. I am running Linux CNC over here on an old computer using a parallel port. This is my control panel. It has the spindle display, all of the necessary safety circuitry in it, and it's being driven by 4 542 servo drivers. I think that's what they're called. I'll leave a link down below in the description of where I got all the things from. The website for the PrintNC, I'll leave all of that down in the description. All right, so I built this enclosure, and you'll notice the foam padding on here, and eventually this will have a door, it'll have a roof. All will be, again, sound insulated because the thing is pretty loud. So what I want to do is be able to close it up and cancel some of that noise out. So that kind of gives you a general idea of what this is. So now let's talk about the projects I'm going to be doing. So I did put T-track in here. There's a lot of different hold down methods that you can use. I decided to go with T-track. The challenge is these hold downs are kind of high. They're made out of aluminum. And it will cut through there. It won't cut through the bolt if it does accidentally hit it. So what I want to do as the first project is I want to make some wood hold downs, and then I will have some shorter screws and the top will be, you know, this plastic. So if I do accidentally hit it, it won't go through it. So let's get started on that. And let me show you how I go ahead and get everything ready for it. So what I've got is a piece of MDF attached to the spoil board with these clamps here, these metal clamps. And what the purpose of that is just to be able to protect my spoil board as I, you know, get used to it and get the depths really defined. I don't want to mess up my spoil board right away. So what I'm going to do is I'm going to hold this down with some tape and some Starbond CA glue. Once it's on there, it's hard to come off. So that's what I'm going to do is I'm just going to go ahead and lay that down, and I'll speed through that, and then we'll get this thing zeroed in. All right, so now that I've got them on the workpiece, I can line it up here. Oops, tape stuck to it. I can line it up here, and now I kind of know where to put my tape on this fixture. All right, so now I'm just going to put a little bit of CA glue here. It doesn't need a lot, just a little bit there in the middle. And I'm not going to use any accelerator. It really doesn't need it. So then I'm just going to line this up. Press it down, give it a minute, and it will stick down. And then, so just while this is drying, I do have this piece of MDF aligned with the grid on the spoil board because this grid was cut by the CNC. Therefore, it is square and parallel to the CNC, the spindle and the Y gantry, or X gantry, I should say. All right, so then I also have a wired game controller here. It's made by Logitech, and it just allows me to move the spindle around without being attached to the keyboard. So I'm just going to move it in place. And what I want to do is get it to where that X is. Okay, I'm going to lower the spindle. Okay, and that gives me a better idea of where it's at. That's looking pretty good. It needs to go back just a little bit. Okay, so that's good. Now I just want to lower the spindle enough just to where it scratches. You can use a piece of paper here, but I found that this method actually works great. So now what I need to do is take you over to the screen and show you the how I zero it out, and it knows the coordinates of where it's going to be. So I do apologize, I don't have very good screen capture on here, so I just have to do it through the camera. So anyway, I want to switch over to G54, and I want to zero everything out. And so now that's going to tell the machine that where I'm working at is the center of the workpiece. In the software where I design these, which I'll put these down in the description, I also have it going from the center of the project. So that's what's going to actually drive that. So now that I have the Z zeroed out, I'm going to raise the spindle because I want to put my dust boot under it. And I just have this dust boot printed, and you can see the magnets here. So it allows me to change the bits and then be able to put the dust boot back on there so I can keep the dust down to a minimum in the shop. Okay, so now let's go in and find our file. Okay, and here's my hold down clamps. Let's go to overhead view so you can see it. All right, I'm gonna put my earphones on because it gets loud. Turn on dust collection and hit go. It's just telling me to insert the tool 1, which is already there. By the way, it's a 1/4 inch down cut end mill. Alrighty, let's pull them up. Okay. And now I'm just going to hit some of the edges here with a little sandpaper. Okay. And then just put a little T-bolt in there. And what I want to do is show you what the difference is in height-wise, these versus those, because you saw me moving them out of the way because the dust shoe was getting on there because it's so tall. But here, when you do it like this, look at the height difference here between here and here, and you see it's all, this is actually even with this the top of the stock, so it wouldn't hit it, so I wouldn't have to move it out of the way. So anyway, so I'm going to get the rest of these clamps ready. These are probably a really good project to start with when you first get into your CNC. Now what I'm going to do is get this all cleaned up, and I'll show you that next project. Alrighty, about the same setup as before, but now I've got the new clamps that we just made. This is a piece, I glued it up yesterday. It is about 3/4 inch thick. It's 7 by 7. It's got a little bit of cherry and maple. Let's talk about some things that I want to upgrade. Two main things that I want to upgrade is that's an older computer. It's very noisy. The fans are too hard to get to replace. So what this is actually a computer. It is a small computer. I've already got the software installed on it. It's got 2 Ethernet ports. So what that'll allow me to do is connect to this. So right now, it's got a parallel port in it. If you don't know what that is, think about old printers and how you used to plug them up with that really thick cable. So instead, it's just going to use a network cable to go from there to the back of here, and that just allows for quicker communications with the CNC, fixes some of the any latencies, and it also gives a lot more inputs, outputs for things like a remote start and stop switch rather than clicking it on the computer. It allows me to expand the CNC past what that parallel card is able to do. So that's a big thing that I'm going to upgrade. The next thing is I need to finish this. As you can see, it does not have a roof on it, so I want to put a roof on it. I want to put this foam insulation on it, get some doors built here, and have like plexiglass or Lexan or something like that, so that I can see the machine and see what's going on with it. All right, now if I take you down here, so this is my, my laser unit that you see here. You've seen it, I've made a couple of videos. It's my Taytools down here. What I want to do is, since this computer is going to be going away and that little one I'll mount on the outside, I want to fill this with a cabinet. So I need to build a cabinet so that I can keep my bits, make a bit storage tray in there, and then have maybe something down here to have like scrap wood, things like that. So yeah, so those are all of the different things that I want to expand, upgrade, and just finish out on this machine. Alrighty, so that's going to wrap it up today. I hope you enjoyed it. If you have any questions about, hey, how do I get started into CNC? More information about the MPCNC that I mentioned at the beginning, more information about this, drop a comment, leave me an email, something, let me know, and I'll get back to you and try to help you out as much as I can. I'm really stoked with the way that this turned out. It turned out so well. I still need to put a couple more coats on it. And then I did this one off camera. Let me see if I can bring it in for you to see. It turned out well, except for a little boo-boo here. Didn't have my height set right, and so it plunged the bit into the wood, just was turning at 18,000 RPM and burnt a little hole. But this is pretty cool, so this is another option that you can do. So a lot of different things you can do with the CNC. So anyway, that's going to wrap it up. If you enjoyed it, give me a thumbs up, drop a comment, subscribe, put on that notification bell. All of those things help me with the channel. And until next time, I wish you and your family a blessed day. Thank you.